Hey, my dear viewers, it's been a while, but I'll make it up to you because I have a very, very special guest, as you might have seen on my social media channels. Uh, no one else than Professor Avi Loeb. Oh, I have to put it this way. Okay, so we're about to go live with Professor Avi Loeb. He has not been sitting still, amazing discoveries, and I just want to know everything about it and pick his brain. So I'm not going to talk too much anymore on my own. Here he is, the man of the hour, Professor Avi Loeb. Welcome, sir.
Thanks for having me. It's a great pleasure.
It is always a pleasure to have you on, Avi. So there are so many things I could ask you right now, but I want to know one thing first, and that is, how do you feel about what is going on since you guys, you and your team discovered this material? So, how do you feel as of now?
Well, I feel great because we follow the scientific method despite a lot of pushback from people who call themselves scientists. We can talk more about it. And we went there. It was a risky expedition. There were many failure points, but we managed to pull it off and found what we were looking for, the molten droplets from the surface of an object that came from outside the solar system at the bottom of the ocean, almost 2 kilometers deep, across a region of 11 kilometers in size. And these are millimeter-sized spherules, spherical marbles, that we brought back to Harvard University and analyzed them. It's just thrilling to follow, it's like a detective story. Follow the scientific method, look at the evidence, and realize that we have analyzed for the first time in history materials of a big object that came from outside the solar system. So no matter what, even if it's from a natural origin, it's still a historic discovery.
So, of course, you discovered what you were expecting to discover, I guess. But was it anything more than that?
Yeah, I mean, we didn't know what to expect in terms of the material composition of this object. And what we found is an enhancement, a concentration of some elements well beyond solar system composition. For example, beryllium. Beryllium is interesting because it's made by energetic particles, cosmic rays, that break up heavier nuclei. And it could be a flag of an interstellar journey because the flux of cosmic rays in interstellar space is far greater than in the inner solar system, because the inner solar system is protected from cosmic rays by the so-called heliosphere. That's where the solar wind meets the interstellar medium, and there are magnetic fields there that block most of the cosmic rays. So the rocks that we find in the asteroid belt and in the inner solar system are not exposed to the same level of cosmic ray impacts. And on the other hand, if you go through interstellar space, cosmic rays are more abundant and you can get much more beryllium produced as a result on the surface of the object. And indeed, we found an enhancement by a factor of a few hundred relative to solar system abundance of beryllium. But in addition to that, there were elements between lanthanum and uranium that were also enhanced by hundreds of times, up to 1,000 times in the case of uranium. And there, the question is that a result of some natural process? We discuss one possibility in the paper, which is a magma ocean, basically a planet that has the rocks in it molten. The Earth started this way because there was a period of large objects that bombarded it and heated it. So it was all molten lava on the surface of the Earth. And in fact, one of these impacts created the moon. And the moon was a magma ocean to start with. And Mars was at the same time because it was also impacted. So we know of planets in the solar system like Earth and Mars that started this magma ocean. However, the abundances that we see are not similar in concentration, in magnitude to those seen on Earth, the Moon, or Mars. And the idea is that in a magma ocean, if you have an iron core to the planet, some elements sink to the center, they are attracted to iron, and other elements are left behind in the crust of the planet. And those are the elements that we see enhanced. But those magma oceans that we know about in the solar system do not have the same composition abundance pattern. So it needs to be from outside. And then the question is that the challenge is really that you need to make 10 to the power 23, a huge number of these objects like this meteor per star in order to have a large enough population of such objects such that one would collide with Earth per decade. So the Earth moves around the sun, and every now and then it bumps into one of them by chance. And in order to have enough of them so that you get such a collision once per decade of a meter-sized meteor like that, for that you need 10 to the power 23 of them to be made in every planetary, around every star. And that's a large number because the mass of this meteorite was of order 500 kilograms. So if you take 500 kilograms times 10 to the power 23, you get the mass of the Earth. So, yes?
Professor, can I ask a question? And
yes, go ahead.
Sorry. Like my other classmates, I was in front of them. The first thing that comes to mind is this maybe also important for researching the existence of Earth, as you were talking about. This material, like Earth, was created by like these kinds of impact and those kind of materials. Is this something we could learn from, like our own planet, like our own existence now?
We can definitely learn from it, but it cannot be from Earth because you don't see this composition pattern. We call it BeLaU because there is enhancement of beryllium, lanthanum, and uranium. But the abundance pattern is not similar to what you find on Earth, not the Moon, not on Mars. So it needs to be from another planet outside the solar system. And the challenge is really you need a whole Earth mass of magma ocean to be split into 500 kilogram units.
So,
and that is difficult to do. You need so many collisions, so many impact. It's just not reasonable. 10 to the power 23 objects of 500 kilogram like this meteorite. So that's the challenge for this scenario, the natural scenario. And then, of course, there is a possibility that it was made, manufactured by a technological civilization. And for that, elements like lanthanum are used in substrates of semiconductors. So you can imagine using them for some technological purpose. Okay. And uranium, we all know, is used for energy production in fission reactors.
Okay, so let's rewind a little bit. You just stated it could be a manufactured material. Am I correct?
Yeah, it could. We don't know which of these is the correct explanation. I just wanted to mention that one simple way to tell the difference between a natural and a technological origin is to find a big piece of the object, because you can easily tell the difference between a rock and a technological gadget that may have buttons on it.
Okay, so what makes you think this could be a possibility? This could be a manufactured material. And how did it hitchhike to Earth? Because you guys named it BeLaU, right?
Right.
So that
BeLaU
means,
is
that means it's either an accumulation of materials we already know, or is there something new in there?
No, the elements that we find are all from the periodic table, the ordinary matter that we are made of, but the proportions of these different elements is very unusual. It was never seen before in the solar system, because all the objects that were analyzed were from the solar system. This one looks different. And we found those spherules only along the meteor path. We looked also at very distant regions that we call control or background regions. and we didn't find the BeLaU composition there. So we think that it's associated with this meteor. Also, we found an excess of spherules around the meteor path, more than average everywhere else. So all of that supports the idea that these are molten droplets from this meteor. We call it IM1. That's an abbreviation of Interstellar Meteor 1. But it also can mean, if you listen to it, as if it sounds like IM1 out of a population of objects. This is the first one. And then we also have a candidate for IM2, which you can also think of that it sounds like IM2 of this population. At any event, what we hope to do is in a future expedition, look for a bigger piece. And from that, infer what the object is. And that would require a completely different machinery for us to collect bigger pieces, because we use the magnetic sled, basically a 1 meter wide metal piece that had magnets on both sides. And we basically scraped the skin of the ocean floor for magnetic particles. These were tiny, and it was still very challenging, but finding bigger pieces and distinguishing them from rocks would be the next challenge.
Wow, it seems like an incredible, difficult challenge, actually. But now I'm very curious how this new composition of materials hitchhiked to Earth. What's the theory about that?
Yeah. So, well, it depends on the origin. If the origin is natural, as we were talking about a magma ocean planet that has an iron core, it has to be a result of impacts, that there are lots of impacts on the planet and they kick out droplets of material out of this magma ocean. That's the way the moon was made, and the moon is a pretty big piece, but you can imagine smaller objects. You can imagine smaller objects being made by the same process of collisions, impacts. That's the way it would be done naturally. But in the case of a technological object, since it crashed on Earth, I would think that it was not functional. So just think about the probes that we sent to interstellar space. Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, and New Horizons. They will exit the solar system in about 10,000 years from the Oort cloud, and they will not be functional at that point. They will just be space trash. We are polluting interstellar space with just trash. So a piece of trash like Voyager in 10,000 years could collide eventually with some planet, and it would appear as a meteor of unusual strength, material strength and unusual speed. Just like this meteor was tougher than all the space rocks that NASA cataloged over the past decade. So just like this, can you hear me?
Well, I think we froze for a second there.
Okay. Can you hear me now?
I can hear you fine.
So what I'm saying is, just like Voyager would appear as a meteor of unusual strength, this meteor was tougher than all the space rocks cataloged by NASA over the past decade, 272 of them. And moreover, it was moving faster than 95% of the stars in the vicinity of the sun relative to the local frame of the galaxy, the local standard of rest. It was moving at 60 kilometers per second. So an object moving faster than expected and is tougher in material strength than rocks could indeed be a Voyager-like spacecraft. That's why I was intrigued by this object.
Okay, so does this change your scientific approach to investigating this material? Because now you think it could be plausible, or there could be a chance this could be some kind of intelligent space trash or something, Is this going to change the approach of your scientific research, or are you just going to approach this the same as you were investigating anything from outer space?
Well, we have 700 spherules that we collected. So far, the first paper that we put out is based on the analysis of 57 of them. So just less than 10%. we have a lot more to study, and that would improve, of course, the statistics we have on the BeLaU spherules. Maybe we'll get even better measurements, for example, of isotopes, because radioactive isotopes can be used as clocks to time how long the journey was. So just think, if we were to figure out how long the journey took, then we can take that time that it took for the journey, multiply by the velocity of the object before it entered the solar system, and we would get the distance from where it came and the direction from where it came. In principle, that allows you to find the source star from where it came. So that is a very exciting opportunity. But
Wow.
for that, we need to use radioactive isotopes to date the duration of the journey, the age of the material. But we will analyze, get as much information as possible, and then eventually we hope to do another expedition to look for bigger pieces.
Right. So there is this picture where you show some of the material. It has this very, very, let's say, eye-catching bluish hue to it. How does that? Is that like, it's of course a picture, but is that actually the way that looks, or?
Yeah. So, well, these images that you saw, it depends which one. There are some that were taken with a microscope. That was on the ship. And in fact, they are so beautiful, these marbles, that my daughter wanted me to give one for her to put on a necklace. But I said it's a millimeter in size, you can't thread them. But there were better images obtained with an electron microscope, where you can actually not only see the outside, but we actually looked at the inside of some spherules. And what you find is like Russian dolls. Inside the spherule, there were smaller spherules because they solidified first, and then they were engulfed with liquid iron that glued them together. And so you find spheres inside spheres inside spheres, all the way down to very small scales. And that was beautiful to see.
Well, it looks incredible, and I'm looking to like a great stone for an engagement ring, and I'm looking at you right now. Like this could be maybe this could be a very, very expensive material in that way. I'm just kidding, of course, but not.
I mean, we don't make a profit. I mean, we don't use it for commercial purposes. But you're right. If it's a rare material in the sense that only one in 1,000 meteors we calculated originates from interstellar space. So, most of them just are rocks that were left behind, like Lego pieces from the construction of the planets. Most of these rocks that fall from the sky are just in the solar system. By the way, 1 in 1,000 is roughly coming from the moon generally, and 1 in 1,000 is coming from Mars or so. So these meteorites are often just rocks that were left behind from the early solar system. And having an interstellar object is extremely rare. Once per decade, you get a meter-sized object to collide with Earth.
Well, very, very much congratulations on that. Of course, this is this could be the find of the century, maybe. But it also carries a lot of information, I guess, and you guys must be on it 24/7. Now, my question is, maybe I didn't catch it, and you said it before, but is there any indication you could see where from it could be from, or is that impossible?
Well, as I said, one possibility would be if we can have a clock that will tell us, like radioactive isotopes, that tell us the duration of the journey, because those isotopes have a half-life, so they live for a certain amount of time. And as a result, if you measure the daughter products and the abundance of the parent nucleus, then from the ratio of the two, you can tell how many such periods of time elapsed since the material started its journey. And so it's just like a clock. Yeah. The problem is that usually the best clocks across interstellar travel are uranium decaying to lead. And the
Yes.
problem with lead is what is called a volatile element. It evaporates very easily in the fireball. So you lose, we can see it, by the way, that's another thing we noticed. These spherules have a depletion, a reduction in the abundance of volatile elements, simply because they were exposed to the airburst, the explosion, and those volatile elements were lost. And that includes, unfortunately, lead. So we can't use uranium dating. Uranium has two isotopes, 235, 238. 235 has a half-life of about 0.7 billion years, and 238, roughly the age of the solar system, 4.6 billion years. So these are very useful. There is also thorium that has roughly a half-life of the age of the universe, so 14 billion years. So unfortunately,
if you create a time, you're creating a timeline now, and you are just walking back in the footsteps of whatever
yes,
you stumbled upon, which is a very exciting way of looking at this, of course, because now, if I understand correctly, I'm just trying to make this.
By the way, just to clarify, I had this idea on the ship. This is not something you would find in the scientific literature, because for the first time we found a real object, that came from far away. So this opportunity of figuring out from which star it came was never discussed in the literature.
Look, this is Galileo in full effect, right? Like pioneering all the way, and this is what science should be. Congratulations on that. Now, on that note, how was your discovery received by your peers? Now, even if you're the biggest critic, they must have been impressed by this sketch, right? Or
well, any real scientist would be, because what we did is follow the method of science. Before I went there were a number of colleagues who said, "Why would you waste your time and money?" And I said, "I'm not asking you to do anything. You just sit back and relax. I'm doing the heavy lifting, and let's see what we find." Because if you don't search, obviously you will not find anything. And the money we used was donated. It was not using any additional funds that were allocated to science before. And so it was a win-win situation. And amazingly, we found what we found. And then, of course, some people, the day I came back from the expedition, there was a paper published in the Astrophysical Journal saying, "Oh, the US government measurement must be wrong. The data is incorrect, because when we try to fit it with a model for stones or iron meteorites, we just can't do it. And therefore, the velocity must be 3 times smaller than the US Space Command reported." So that's a year and a half after, the US Space Command issued a formal letter to NASA confirming at the 99.999% that this meteor came from outside the solar system. They said, "No, it's a stone that came from inside the solar system, and their data is wrong." And the US Space Command is the organization that receives more funding than NASA, and its duty is related to national security. It's supposed to alert the president for any ballistic missile heading towards the US. And just imagine if they were so incompetent to get the velocity measurement wrong by a factor of 3, as suggested by these astronomers. I would not sleep well at night, because they would alert Mexico for a missile heading towards Washington, D.C. And we went there. The other point is, we went there and we found something. So why would you publish a paper saying there is nothing and it's wrong and it's a stone, when we actually found materials that are primarily made of iron, and it's clearly not a stone? And we found all these BeLaU composition elements. So it just sounds to me like these are people who call themselves scientists, but they are actually working against the scientific method. They express an opinion. They dispute the data when it doesn't fit their model for stones. And I call that the Stone Age of science, where everything in the sky must be stones, and you're not willing to adapt your model to change to data that is not consistent with the model. I started my career in cosmology, the study of the universe. Most of the matter in the universe is not known. 83% of the matter was never witnessed in the solar system. So these astronomers would say, oh, the data on dark matter must be wrong because we can't fit it with our model for stones. Well, guess what? Most of the matter in the universe is not stones. I'm sorry to break the news to those astronomers who still believe that everything in the sky is stones. And you have to be open-minded when data does not support your model, because it's quite possible that your model is wrong. And we haven't yet figured out what the nature of dark matter is. We invested billions of dollars trying to find it, including in the Large Hadron Collider, looking for supersymmetry. We didn't find it. And the point is that if we were to spend billions of dollars over many decades searching for objects that were made by extraterrestrial technological civilizations, and we would find nothing, we would be exactly at the same point as dark matter searchers are right now. And they are embraced by the mainstream. I don't hear these critics about this meteor saying, oh, we shouldn't, this is an extraordinary claim to say that there is dark matter. They don't say that. Why? Because it's embraced by anyone that is curious about the universe allows new knowledge to be gained. You don't just subscribe to past knowledge and say, oh, the data must be wrong when it doesn't comply with your expectations. If you are curious, if you are a real scientist, you accept the possibility that you might learn something new. And unfortunately, I should say, doing cosmology for me many years was like playing chess. And it was always encouraged to think about possibilities for dark matter so that the experimentalists will search for it. It's just like playing chess. You're trying to find smart moves. And, working on objects in the sky, like it looks to me like mud wrestling, where those mud wrestlers just want to drag you into the mud to fight with them. I don't want to fight with them. I'm just exploring possibilities by following the scientific method. So I would rather bring this subject to the level of chess playing. And the other metaphor that I would like to mention is that, I prefer to adopt the method of the eagle. Very often the eagle has a crow on its back that is pecking on its neck. And instead of fighting the crow off the back, the eagle rises to great heights where the oxygen level is low, and then the crow drops off. And so that's my approach. To rise to the highest levels, which means that I'm trying to do my science to the best possible way so that the crows will drop off my back and stop pecking at my neck. And to my surprise, after the paper was published, and we are already a week after it was posted on the archive, these crows keep pecking at my neck. They don't even read the paper. They criticize the paper without reading it. I'll give you an example. There was a figure in the paper where we showed that the abundances of some elements are hundreds of times to 1,000 times bigger than in the solar system material. Then one of the harshest critics, which goes around to reporters and says bad things and bullies all the time what I say, this guy was tweeting and saying, oh, after 20 minutes, I found a plot that looks just like that. And he shows it on Twitter as evidence that it's nothing new. And you look at the plot, and the vertical axis in terms of how much deviation from the standard solar abundances you see are always within a factor of 10. We are talking of up to a factor of 1,000. And the guy is using the fact that the plot looks similar without seeing that he's talking about factors of 10. We are talking about factors of up to 1,000. So it's just, and this is supposed to be a person that specializes in space rocks. And everyone says, yeah, he's just shown us that it's nothing new. But look at the plot. It's completely new. And we know what we are doing. So I'm doing the work professionally. And what I find distressing is that those people are just trying to criticize and bring it down, not being smart, actually. Because if they were smart, they would actually pay attention to the details.
Well, Mr. Loeb, how dare you mess with their axiom? Because they, of course, they are the authority.
Let me say the following. Let me say the following on that point. If they have a psychological issue with the data, they should speak to their therapist. That's not my problem. My problem is not their psychological issues with the data. I'm just showing the data, but they should not distort the data as if it's something that they've seen before.
Yes. Well, I guess this is nothing new, right? Whenever there's something very, very new, a new discovery, people get scared. I guess even scientific people with a big reputation. But maybe correct me if I'm wrong.
These are, by the way, these critics do not have a big reputation. Believe me, the ones that have a big reputation, I get very supportive emails from. I just posted on medium.com. You can read of people. There were 2 essays over the past week that detail email messages that I received, which are extremely supportive, and they are inspired by what I do. And a lot of people tell me that scientists, real scientists, those who attack me are a small minority of people that just have a psychological problem with this.
Of course. Well, I guess the stages of new discoveries are: first you'll get ridiculed, then they'll try to fight you before they will accept the new discovery. I guess.
Oh no, they will not accept. They will just say, "Oh, we knew it from a long time ago."
Right.
That's what they will say after it becomes obvious. Yeah.
Of course,
it's
they were already part of it.
Yeah, it's nothing new. We already said that. They would say.
Yes.
Yeah.
But let's try to forget the let's say the ignorant, and move on to what's next. Because my next question is actually, you guys must look at whatever BeLaU is in a way. This is apparently a brand new composition that could be possible evidence for something that was manufactured. Now, is there any information you can get from whatever you are researching right now, the material you retrieved, that already gives a hint to the composition? It would be composed by something intelligent.
Well, so we have more work to do. For example, isotopes, radioactive isotopes, various isotopes of different elements, that could bring us a new layer of information that we have not yet revealed, because so far we just focused on primarily on the elements, what is the concentration of different elements, and already we see something unusual. So let's see what the coming months will bring in terms of better data. We are doing our best, and one reason I wanted to put out the paper, I mean, a lot of people were waiting for the data after we returned from the expedition, because it was the first time that we attempted to retrieve materials from an object from outside the solar system, and a lot of people were excited. There was a lot of discussion, and we ended up analyzing 10%, about 57 spherules, and released the information that it's already quite intriguing, but we want to do more work, and I wanted to get some feedback from people who are constructive, like if they have something to suggest to us in terms of how we should analyze it. I want to listen to that before we engage with most of the sample that we have. But we also plan to go again and find bigger pieces, find more spherules. So this is work in progress. And when I was on the ship, I wrote 43 diary reports, and millions of people around the world were inspired reading them. I got a lot of fan mail, including someone who said that he had a stroke just a couple of weeks earlier, and this gave him a meaning to his life. Reading about how science is done. People were really grateful. And I should say, those that criticized the work, they said, why would you communicate with the public before your paper gets accepted for publication? And the point is, they're completely wrong, because the public enjoys seeing work in progress as a detective story, where you see how the scientist retrieves evidence but makes mistakes, tries to find out the truth. That's a human activity. If a scientist just shows an image of always being right at a press conference with the final results, it does look like an occupation of the elite, where the scientists feel superior to the public intellectually, which is pretty much what many scientists would like to feel. But I say that's not the way science should be done, because funding is coming from the public. So first of all, the subject is of great interest to the public. I should not hide anything. I'm telling the public what we are doing, and people were inspired by that. For the first time, a lot of people said, for the first time, we see how science is done. And I see that as a great benefit. And I also want to use this opportunity to teach some of my colleagues, scientists, about how science should be done, rather than expressing an opinion and not doing anything because you say, oh, this is an extraordinary claim that requires extraordinary evidence. Everyone that says that is not seeking the evidence. And you have bloggers and science popularizers who do not practice science. You know, some of the most famous personalities, they want to be popular, but the point is they are not doing science. So they are just like commentators looking at a soccer match and telling the players how to pass the ball. I mean, I am doing the science and also talking about it, but I'm doing the science. I write a steady stream of scientific papers all the time. And I'm not on the same level of those people who just don't do any of. Many of these bloggers or science popularizers didn't write a single scientific paper over the past decade, a single scientific paper. And they tell me what to do when I wrote more than 1,000 papers. So my point is simple. If you are a commentator, be humble, because you are not supposed to tell the players on the soccer field how to pass the ball. You can have an opinion, but you shouldn't feel as if it's your duty to push back against the progress of science.
Mr. Nightgazer has a great point over here. He said, look at you, Neil deGrasse. Looking at you, Neil deGrasse Tyson. Well, Neil has a reputation for basically killing every discussion that is in any way outside of the scientific axiom.
Yeah, but my point is simple, Max. My point is that he's not practicing science. He's writing about science, okay? Right. And there is a clear difference. There is a difference between doing what you preach, okay? And the difference is that you are actually doing it. You know, just think about the metaphor of soccer. If you are playing soccer, you know, on the field, it's a very different thing than to sit on the bench and make comments about it. And what these people are doing is expressing their opinion as if they are quote unquote astrophysicists, but they are not astrophysicists. To be an astrophysicist, you need to write scientific papers in astrophysics that are refereed, that are peer-reviewed, and then published. And, you know, I'm doing it on a steady basis with a few papers every month. I'm doing it all the time. Now, I'm also talking about the science that I'm doing. They have a problem with me talking about the science that I'm doing. They are not doing science, many of these commentators.
I get it. And it's also opinions, and opinions are like assholes. Everybody's got one. So let me get back to this, because you are actually doing something that is also pretty much pioneering, and that is involving the people who are interested, the public, and making your science transparent. And you know, you share the scientific process you're going through. That doesn't mean you're concluding anything. That doesn't mean you're trying to push some kind of a truth. It's just you are involving people who are interested in the work you're doing.
You know, one thing about me, I'm not manipulating people, and that was true from when I was a child. I just say what I think. Some people don't like it. You can see that.
I've noticed.
But the point is that I'm actually practicing what I preach, and I'm actually doing it, and I'm sincere about it, and I don't feel superior to the public. You see, when a plumber comes to help me to fix the sewer, there was once a problem. You know, I had a few-hour conversation with him afterwards, just sitting, you know, on the stairs and talking about life, about everything. I don't feel any sense of superiority or difference from anyone in the public. I feel that I am a member of the public. I grew up on a farm, and I'm just curious, and I'm really grateful for being given the opportunity to use the scientific method to answer questions that people care about. You know, there was a colleague of mine at Harvard. Actually, he's not at Harvard. He was pretending to be at Harvard. Here again, some people are pretending. He was pretending to be a Harvard astrophysicist. He was not. He's not related to Harvard. Anyway, he was quoted in the Crimson, the Harvard student magazine, as saying, you know, it's about time that reporters will pay more attention to boring science. He said, it's true that some people are jealous of the attention that Avi Loeb gets, but it's about time that reporters will pay attention to boring science. And my point is, why should the reporters pay attention to boring science? Why don't you do something that the public cares about?
Well, Avi, let me ask you this question. Is this like a scientific group dynamic, and people are just being afraid to be, let's say, confronted by their peers or their group?
Yes, but it has some peer pressure aspect to it. But you have to understand, Max, that in this the mainstream of theoretical particle physics for more than 40 years, people were working on speculations that are far greater, okay, than considering the possibility that extraterrestrial intelligence exists. Far greater than that. People were talking about extra dimensions in string theory, about the multiverse. These are ideas that have no foundation in experiments. Nothing. We don't have any evidence for them. And it's not clear that we will have in the coming century. Yet, it occupies center stage in theoretical particle physics. If you speak about extra dimensions, why? Because it offers a sandbox for people to do intellectual gymnastics and show that they are smart. And as long as the name of the game is showing off that you are smart and doing mathematical manipulations, and you have hundreds or thousands of people doing the same thing, it's accepted. Let me give you an example. Half a year ago, I had breakfast with a string theorist. And I asked him, what's your most important paper? And he said, it's a paper about supersymmetry. This is one of the leading scientists. And I said, yes, but actually supersymmetry was ruled out by the Large Hadron Collider in the natural parameter space. So why would you think about it as an important accomplishment? Because so far we haven't seen evidence for it. And he said, well, it may be just around the corner. The next collider that smashes particles at higher energies will find it. And to me, it immediately reminded of the Jewish Orthodox community in Brooklyn, Crown Heights, the Lubavitchers. They had a rabbi.
I'm one of those.
And they thought that the rabbi will become a Messiah. So
right.
The idea is that when the Messiah arrives, the Messiah will come to Israel. And so they built an apartment for him in Israel that is a replica of his apartment in Brooklyn, so that he will find the toilets easily. This apartment exists in Israel. So they built it. They believed he will become the Messiah as soon as he dies. And then he died. That was a data point. Just like supersymmetry was not found by the Large Hadron Collider, here he died and didn't come back as a Messiah, a data point. Okay, so how did they respond to that? They said, well, we just have to wait. And now I ask you, what's the difference between a string theorist saying we just have to wait for supersymmetry to be found, and the Lubavitchers saying we just have to wait for this rabbi to become the Messiah? The difference is that the scientists are supposed to respect data and say that an idea, is not relevant anymore, but they don't. My problem is they don't. They don't respect data when the US government, the US Space Command says this is an interstellar object. They say, no, you are wrong because my model for stones doesn't match it. That's arrogance.
That is actually. Now, you touched down a few moments ago on like your investigate your research on whatever you've retrieved, and you said there's new information, or there's things you haven't revealed yet, that came up. Can you elaborate on that a little bit more, if you can?
Well, no, I mean, the paper details what we have. And one thing that I'm thinking about, it's not clear yet if it will be feasible, is just like when you have a recipe for a cake, it includes the ingredients with different proportions. And it tells you that if you mix them together, you can get the cake. So now we have sort of a recipe for IM1, BeLaU, a composition. We can just take those elements with the relevant proportions, put them together, and see what we get. Maybe we'll get material with unusual properties like thermal conductivity, electric resistivity. Who knows? As you know, there was a lot of discussion about the room temperature superconductivity recently. Anyway, so we can do that. We can, in principle, put these elements together with the right proportions in the laboratory. The only missing part is those volatile elements that, as I mentioned before about lead, that evaporated. So we would have to play with that as to how much of them to add. But other than that, we can try and see what cake we get. And actually, it may be quite pricey to do it in the laboratory because some elements are very expensive. But another possibility is to do it on the computer. There are AI assisted simulations that try to reproduce the properties of materials based on their composition. So I'm looking also into that possibility.
Well, for some reason, last weekend I went to see the great movie Oppenheimer. Did you see it, Mr. Loeb?
Oh yeah, I loved it. Yeah,
I loved it too. But your story kind of reminds me of this process they went through, right? Like, there was this, let's say, layer cake. You were talking about that. Eventually ended up in something terrible.
Right.
This is not what you're working on, but this.
Well, I should say about this film just a few things. One, that I think the success of the Manhattan Project was a result probably of Enrico Fermi, because he knew both theory and experiments. He built the first nuclear reactor at Chicago.
Yes, sir.
And he was an amazing physicist. I read many of his notes, that were never published in a textbook, but he just had an insight into the physics, and he knew how to get things done. So if I had to guess, I would say he was probably responsible for the success. And on behalf of Oppenheimer, I think he was naive. He was naive to assume that he will have any authority about how to use the weapon once you develop it. He should have developed it only under the assumption that he supports any use of it by the politicians. But then he was somehow disappointed that he didn't have that opportunity to voice his opinion about how to use, because as you can see from the movie, the general tells him at the end, after they develop those bombs and they are carried on a truck, he said, thank you very much. From now on, it's under the jurisdiction of the politicians, the president. And he was surprised by that. And then the other thing that was interesting is the relationship with Albert Einstein. And Einstein was wiser and on many different aspects. For example, Oppenheimer always wanted to be remembered for his contributions to theoretical particle physics, whereas the thing that he's mostly remembered for is the solution that he derived with a student for the collapse of a star in a spherical fashion, a collapse of a star to a black hole. This is remembered by astrophysicists, and he always thought about that as applied physics, just explaining a phenomenon in nature. He thought of that as lower class physics than theoretical. But he is actually remembered for that. And this is just an important lesson that if you deal with the reality, things that you see in reality, like black holes or stars collapsing to a black hole, that has a bigger chance of being remembered than doing intellectual gymnastics about extra dimensions, for example.
Yes. So you touched down on something that that is very much now talking to you, like at the end of Oppenheimer, the military took the research, they took everything they developed and just ran with it, and it was just out of his hands. Could this be, and like God forbid, be something that could happen to you?
I don't think so. I don't think
hope
so,
not.
and I'll tell you why. I get full support from people in Washington. For example, the U.S. Space Command wrote this letter to support the interstellar origin of this meteor. That took time from their day job, which is related to national security. They were willing to support blue sky research, the frontiers of astrophysics. They dedicated time to check the data and confirm the conclusion in a letter to NASA. That shows you that they care about basic science. And
Right.
Also during my expedition, I got supportive emails from Washington. And so far, all the interactions I had were supportive. There was never any hint of concern.
Now, not too long ago, Bill Nelson of NASA's Bill Nelson, he is actually kind of in your slipstream, I guess. Now, stepping up the game, NASA, okay, so they're claiming publicly, we're going to step it up and look in a certain direction. How do you feel about that? Now NASA is getting more and more involved. Because let me just finish. Because you in a previous episode, you were at my guest earlier on a couple of times. Actually, you called out Bill Nelson,
right?
And you called out Elon Musk. Now it looks like the both of these, they changed their tune a little bit. They changed their tone a little bit, right? Now Nelson, I guess, is navigating more towards looking, out of the box of whatever now is, their pre-assumptions, and also Musk. How do you feel about that? Because I think that is something you might have, this chain reaction you might have, caused.
Yeah. So what happened was that 2 years ago, on June 4th, 2021, Bill Nelson made a comment in anticipation of the report from the Director of National Intelligence to Congress, saying that as a senator, he saw classified data on unidentified anomalous phenomena, and the hair in the back of his neck stood up. He said that he was intrigued, and therefore scientists should get engaged. And the following morning, I sent an email to the person under him responsible for science at NASA, Thomas Zurbuchen. And I said, I'm here to make your boss happy, and I'll be glad to promote this initiative. And then Thomas said, why don't you send me a white paper, which I did. And it became public afterwards. But I never heard back from NASA, and I established the Galileo project, which we now have for more than 2 years. And we built an observatory, and we are planning to make copies of it. So anyway, then a year later, I had a celebration for my 60th birthday at Martha's Vineyard with my students and postdocs. Thank you. And at the end of that, someone says, did you hear about NASA announcing a study? That was more than a year ago. It was June 2022. And I said, no. And then I wrote to Zurbuchen and said, look, you just ruined my week. I had a wonderful week. I asked you whether that can be pursued. You told me that I will send a white paper, and then I see that you established a study without me. And the answer was, well, you already established the Galileo project, and therefore, you have a vested interest in the subject. We cannot put you on the committee because it's supposed to be impartial. And I find that like an oxymoron, because suppose they were to initiate a study of climate change, would they avoid scientists who were engaged in the study of climate change on this committee? It sounds strange to me. At any event, that they are supposed to deliver the results from this study. I met with them twice, representing the Galileo project, and they wrote their report, and it's not out yet. So the question is, what will they recommend? And obviously, I mean, the natural thing for them to say is we should find more data on unidentified anomalous phenomena using well-calibrated instruments that are fully under our control, which is pretty much what the Galileo project has been doing for 2 years. And on that, I would say, just like Oscar Wilde said, the imitation is the sincerest form of flattery. So if they're imitating the principles of the Galileo project, I feel flattered. But that's all I can say, that it's 2 years too late. We could have started the real progress 2 years ago, and we did with the Galileo project. And then, at the same time, there is ARROW, the All Anomaly Domain Resolution Office in the Pentagon, and they just last week announced a new website, and Hicks, the Deputy Secretary of Defense, she will be responsible for this office directly. And that must be a result of the hearing in the US House of Representatives, where David Grush talked about those programs, and perhaps Congress people want more transparency and more info. But at any event, it brings it to a higher level of importance. We should see what is being reported on that website. Altogether, with respect to Elon Musk, I should say, a few months ago, he had an interview in which he said, I'm the space guy. I know what's out there in space, and I can tell you that I haven't seen evidence for aliens. And, to me, it sounds like, just like the region that Elon Musk is surveying is the region around the orbit of the Earth around the sun, which is 10 to the power 15 smaller than the size of the universe. So it's yeah.
Well, I don't know if you've noticed, but I know exactly what you're talking about, this statement Elon made. But just a few weeks ago, he tweeted something remarkable, and it was, I'm not saying there's aliens, but ...
Okay, I would like to explore the ... with him, because we need more funds to be allocated to the search. If we don't do the search, we will not find anything. So, Enrico Fermi asked, where is everybody? And of course, that was a lazy proposition, because he was not using telescopes. I mean, it's just like a single person at home saying, I don't have a partner because nobody is standing around me. But in order to find a partner, you need to go out of your home, go to dating sites, go look through the window, check your backyard. I mean, you can't just stay at home and say, I don't have a partner. And that's the Fermi paradox, which is often repeated. But Fermi was in Los Alamos at a particular day, having lunch. And why, the universe is so vast, and the time usually is measured in billions of years. Why would he see next to him evidence at that time during his lifespan? And you need to search for those things. Nobody said, I don't see gravitational waves, therefore they don't exist. I mean, it took us decades to build LIGO to look for gravitational waves, and they were detected. So things don't fall into your lap. You have to invest effort in seeking the evidence.
Can I ask you something about gravity? Now, you were just touching down on David Grush and whatever these military men are encountering in the skies. Now, my question is this. Let's talk about the fundament of the Galileo project, right? So these guys are encountering things that are anomalous. The Galileo project is a transparent effort to share whatever the DoD or the whatever agencies cannot share. Now, I know there was a collaboration with Mr. Mellon and Mr. Elizondo. I've had you guys on the show. We talked about that collaboration. Now, how does this collaboration work right now, doing what you're doing? Is this something that is is this effort involved in the research you are doing right now?
Well, they are sort of advisors as to where we might want to look. But what we are doing is the most important aspect of the Galileo project is the fact that it's systematic. You see, all the reports from military personnel are anecdotal. It's military pilots that happen to be at the right place at the right time, like David Fravor or Ryan, Graves. But
well, there is a little bit of data. There's a little bit of data.
No. I'm not talking about data. I'm saying it's very different than monitoring the sky 24/7, okay, in many different locations, because then you know if something is really unusual. If most of the time you see balloons, drones, and things like that, and then you see something completely different, you have a reference to compare it to. That's called the systematic study, where you monitor the sky all the time at many locations. And then when you see something unusual, you know that it's unusual because you have the background objects that you already looked at many times over. However, if by chance you happen to be at the right place at the right time to see something unusual, you just don't know what it represents. And that's the difference between anecdotal search and a systematic search. And no one did a systematic study of the type of the Galileo project. So that's one important difference.
So let me ask you this. So let me ask you this. I'm not sure if there's any correlation to whatever Commander David Fravor saw, but Commander David Fravor saw something coming out of the ocean. Now, you found something in the ocean, but of course, it's interstellar matter, right? But could there be any correlation to whatever Mr. Fravor saw and what you retrieved?
Well, so we don't, the data that was collected that day when they saw the TikTok incident, that data is not available to us, so we don't know exactly what happened. But in principle, if you just ask me, what is water good for? Well, if you can break the water molecules to oxygen and hydrogen that make up the water molecule, you can use that as fuel, because both hydrogen and oxygen are combustible. They are good fuels. And actually, that's what is being discussed in the context of the moon. For example, if we go to the moon, instead of digging for oil, as we do on Earth, you can look for water, ice, and then break it up using electrolysis, which is a process that uses sunlight to break up generate electricity using a photovoltaic cell, and then break up the water molecules into hydrogen and oxygen and use it as fuel. That is a very good approach when you go to places where there is only water, ice. Oil was produced by animals that died and were processed. But water, ice exists everywhere. And so in the future, when we go to space, that could be a very important reservoir. And in fact, you can think of, just like the oil companies on Earth, space companies that take advantage of oil and distribute it and, break it into hydrogen and oxygen will be as wealthy as oil companies on Earth.
So, look, I'm not a scientist, and correct me if I'm wrong, but these materials you've retrieved, could those be echoes of fuel?
No. So what we found is just the molten spherules, the molten droplets from the surface of the object that crashed into the atmosphere. Nothing of it was, nothing survived. But what Fravor was talking about is functioning devices that were moving around intentionally. They were not just following, the force of gravity, which is pretty much what happened with the meteor. Sure. So the difference between the two, I would say, is the object that I'm studying is probably space trash. It's not functional anymore. It could have been technological to start with, but it's not functional because it crashed. Whereas the kind of objects that he was talking about are functional. And the fundamental question in his case is whether these were, human-made, either by the US, some technologies that he was not aware of, or by adversaries. So that's the fundamental question. Could it be representing human-made gadgets that he was not aware of?
Well, the behavior of whatever he observed, like any scientist I've talked to or that I've read about, says if this were human technology, it would have been like nano ages in front of whatever we are capable of doing now. So how do you look at
Yeah.
that then?
But another thing to keep in mind is if you have a swarm of objects, well, it's just like having a lot of cars on the highway. And suppose you look at the car in front of you, a black car, and then you look at your rear view mirror and you see a black car behind you and you say, wow, that's amazing. This black car moved so fast that, within an instant, it moved from being in front of me to behind me. That may be not the same car. So, to have a decent analysis, we really need the data so we can tell it's the same object that was moving so fast the way he described it. Another possibility that some people raised was that these were not physical objects, that they were somehow, just like
Dimensional, yeah.
Like a laser spot that is fooling a cat, moving around, and it's not a real object.
Right. Yeah. That's the Midwest approach, which could be plausible. You never know. So, does again, Mike? Let me get back to the question. whatever these military men are noticing or have noticed, is this something you take into account during your scientific process?
Definitely, because we need to know what we are looking for. Okay, and it would be the same type of objects that were mentioned in the reports of those pilots and other people. And so we built instruments that could detect those things. So we definitely pay respect and attention to what was reported, but then we want to collect better data and data that will be shared openly, because the sky is not classified. It's only the sensors that are used by government that are classified.
So let me ask you this question. So you zoomed in on this spot near Papua New Guinea. Can you elaborate again? Why did you look at that spot? Why were you looking for material at exactly that place?
Because there was a catalog that was made public by NASA, the Jet Propulsion Lab of NASA. That it's called the CNEOS catalog of meteors, and it had 273 meteors, and you can find it online. It has a map of all the meteors. And the idea that I had was I was interviewed about another meteor over Kamchatka that exploded at the second half of December 2019. And just a few weeks later, there was a radio interviewer who wanted to speak with me about it. So I started checking online what's known about meteors, and I found this catalog. And because I worked on Oumuamua before, and it was intriguing to me, it was the first reported interstellar object, then I said to my student, why don't we check if inside this meteor catalog that I found that the government releases through NASA, if there is, based on the velocity measurements, the fastest moving objects perhaps are not bound to the sun. Perhaps they came from outside the source. That's how we found it. And they gave the coordinates of where the explosion, where the fireball of this meteor appeared. And they gave it with a precision of 11 kilometers on the side. So that there was an error box that we went to crisscross with our ship. But before we went there, we were able to narrow down the meteor path to a strip of roughly 1 kilometer width and almost 10 kilometers length by using data from a seismometer in Manus Island, Papua New Guinea, that detected the sound from the explosion. And from the delay in the sound, just like when you hear a thunder, there is a delay. The sound arrives after the light. Right. And so from the delay time, you can figure out how far it was. So the explosion in the case of this meteor. So we were able to narrow down the position, the path, the likely path of the meteor. And amazingly, we found a concentration of spherules, an excess of spherules along this path, which to me confirms that we were in the right place. So I sleep better at night because I know that the US Space Command did a decent job on this.
Well, you were dead right, because you retrieved it. So that's amazing, actually. Now, let me ask you this. You were touching down on Oumuamua. Do you have any indication that whatever, because Oumuamua was supposedly a meteor, but you said it could also be an intelligently moving or a fabricated object. Did you have the same theory about whatever you retrieved from the bottom of the ocean just yet?
The same theory for
the reason why you were researching this meteor material on the bottom of the ocean, did you beforehand thought, I'm gonna look into this crash because this looks out of the ordinary?
Oh yeah, I mean, it was the speed of the object, which was not only unbound to the sun, but also faster than 95% of the stars in the vicinity of the sun.
Relative. Did you know that? Sorry, but did you know that before you went to retrieve the material?
Yeah. No, that was the motivation for doing the expedition, because it had the two peculiar qualities. This meteor. One is that it was very fast, and the second is that it was very tough in material strength because it maintained its integrity to very high stress. So that was intriguing to me because not only it came from outside the solar system, but it also had qualities that you would expect for an object like Voyager colliding with a planet. So that's why I went there. Now, we don't know, I need to clarify, we don't know the size, the actual size of the object. All we know is a certain amount of material, 500 kilograms of it were ablated from it. But it could be just the surface of the object, maybe a bigger chunk of the core of the object survived. That's what we would like to find if it exists at the bottom of the ocean.
Okay, now something completely different. So, Mr. Loeb, you grew up on a kibbutz or moshav?
Moshav,
yes. On a moshav. Now, I've been to Israel many times, been to the desert, and at night, as you lay down on your back, you look at the stars, there's a lot of stars, right? So now my question to you is, let's say a young Avi living with his parents, you go out at night, you look up on the stars. What motivated you when you were a young man to look into whatever is going on upstairs? Was it you lying down on your back at the moshav, looking at this, no light pollution, just a clear view of whatever is right above you? Was that what inspired you to become whatever you are now?
No. I was mostly interested in philosophy at the time because it addressed the most important questions about our existence. I was fascinated by existentialist philosophers like Jean-Paul Sartre and Friedrich Nietzsche and Albert Camus. I read many of their writings and was fascinated because they addressed important questions about our existence. And I wanted to become a philosopher, but in Israel, you have to serve in the military. That's obligatory. And I was good in physics and math. And they recruited me to a program that selects 2,000 people at the right age to go to the military, 2,000 out of several thousands that are recruited. And we ended up at a special unit that allowed us to finish degrees in math and physics while serving in the military. So, I drove tanks, I parachuted, I had actually a military experience. And actually at one time, I was asked by the commander whether I'm interested in becoming a member of the Delta Force because...
okay, stop it right now. I just want you to know Avi Loeb is a badass.
Well, I jog every morning, but athletically, I was at the top of my class of 1,000 people in high school in sports. But then because I was interested by intellectual pursuits, I said no, and then I finished my PhD at age 24, and it was around the time during this program that the Strategic Defense Initiative was proposed by President Reagan, and General Abramson was the head of that, and he visited Israel, and we presented the project to him, and he selected it as the first international project supported by Star Wars, the Strategic Defense SDI, and that brought me to visit Washington D.C. Oh yeah, here it is. Yeah, so you might say, well, that's an interesting connection, but no astrophysics at the time. I visited Washington quite often because they provided support for the project. And then in one of the visits, I went to Princeton, New Jersey, and the Institute for Advanced Study, where Einstein was a faculty member several decades before. And I arrived, and the administrator said, well, you know, everyone is busy here. The only person who has some free time is Freeman Dyson from the Dyson Sphere. You know him. I said, great, I'll be glad to speak with him. I knew his name from textbooks. I arrived to his office, and he said, do you know John Bacall, another faculty member who works in astrophysics? And I said, no, I've never heard of him. And then he called John, and we had lunch. Gladly, John was around on that day. We had lunch, and he invited me for another visit of a month, and then offered me a 5-year fellowship, which is very lucrative. Wow. That's what everyone dreams of getting, and said under one condition, that you'll switch to astrophysics. So I said, okay, well, I wanted philosophy, but this is a sacrifice I'm willing to make because this opportunity doesn't come up every day. And then after that, someone asked me to apply to a faculty position at Harvard, and I applied, and they selected someone else, and that someone declined because the chance of getting tenure is very small. You know, it was once every couple of decades. But then they offered it to me, and I got tenure within 3 years. And then I became the chair of the astronomy department at Harvard. That's how I became an astrophysicist. It was a complete chance of circumstances that allowed me. But at the end of the day, I said to myself, well,
it sounds almost like you were recruited.
Yeah, but I said it feels like an arranged marriage where they tell you who you're supposed to marry. But I realized later on that I'm actually married to my true love, because in astrophysics, you can address philosophical questions in the scientific method, which is pretty much what I'm doing. That's why you see me so different than my colleagues, because, you know, I'm looking at the big picture. I'm not just a technocrat that solves equations on a particular niche of astrophysics. I see the big picture. I know all aspects of astrophysics. I wrote papers on every subject in astrophysics, and that allows me to realize that, oh, there is actually a frontier that was not explored yet, which is what we've been discussing. So it's the philosophy background that allowed me to have a broader perspective.
Well, I guess they found a great scientific fit for you, for your marriage, your scientific marriage, if one could say. Right. So let's rewind a little bit. In the IDF, your time serving, did you at any point served under Chaim Eshed?
No.
Never?
Never.
Okay, because, you know,
I didn't know him. He at some point wrote an email to me after I became well known. But with respect to him, he never provided any evidence about what he's talking. And without evidence, you can't do much with a story. You know, you have to see the evidence to believe it. So it's really, I don't know what to make of it. I mean, if you combine that with Grush, there is some relationship. But in both cases, we haven't seen the evidence. So I'm still waiting for that evidence.
Yeah, for the viewers, Chaim Eshed, I guess, ran the Israeli space program. And he's a retired general. He was a general, right? Yeah. So
Yes. In the intelligence agencies, yes.
yeah. So General Eshed wrote his memoirs and said some wild things. You can look it up if you'd like.
No, I know what he said, but
No, no, not you, the viewers.
Okay.
The viewers. I know,
Okay.
I know, you know, but to give the viewers some context, it's all anecdotal, even in his memoirs. Some hearsay stuff about the American government being in touch or communicating with extraterrestrial intelligent life, and you can look it up if you'd like. But the general kind of ambushed everyone with that biography. Um, but again, Mr. Loeb was elaborating on that, and sorry, continue, sir.
Oh no, I was just saying that there are many people who would claim that they are Napoleon, but there was only one Napoleon. So even though people can say something, it doesn't mean that they have any knowledge of that substantiates what they say. People can say whatever they want. The point is the evidence. Okay, that's the only. If you were, just think of yourself as being on a jury, okay, where you are supposed to decide something, and if the witness doesn't show any evidence, just tells a story, I wouldn't be swayed much, because people have motives, ulterior motives to say things. And you can see that in a car accident. Different people who witness the same event, a car accident, say very different things. You can also see that in the World Cup in soccer, Women's World Cup. Now FIFA is using video cameras to tell what really happened. They don't go around and ask the players. They don't go to the audience and ask them what they think. They just use instruments that have no personality. They just record the data. And that's the way we should approach this subject. Now, it's possible that what Eshed or what Grush were saying is correct. It's possible, but until we see the evidence, we cannot tell.
Of course. But there's something that's remarkable, there were other high-profile people worldwide, say Paul Hellyer, the former Minister of Defense of Canada, said basically the same thing Mr. Eshed said. There are a couple of other people stating the same thing, but it's all anecdotal, every single one.
Well, I should say that anything interstellar should be a matter that is not related to national security, because any object arriving from a great distance across the Milky Way galaxy, started the journey long before humans appeared on Earth. So that journey did not have us in mind. And moreover, they don't care. Those senders don't care about how we split the land between nations. So this should be information shared by all humans. It should be the work of science to figure out what it means. And I very much hope that eventually, if there is anything, it will be brought to the attention of scientists like myself, so that we can help government figure out what it means, and the public should be aware of that. It's just like going out. Suppose you live in an isolated family, and then you go out to your backyard and you find a tennis ball that was thrown by a neighbor. The question is, should you tell your family members, because they believe that they're alone? And my answer is definitely yes, because suppose there is a neighbor, you want to allow your family to close the windows if they want to maintain privacy, or to go out and speak with the neighbor and learn about it, about things that they don't know. I mean, this should not be hidden from your family members. And maybe the neighbor will knock on the door one day. So you can't really avoid the reality that, it's just like with Galileo, that when people said, no, let's put him in house arrest, not look through his telescope, and maybe it will go away. It didn't go away. The Earth continues to move around the sun. And in order to reach Mars, we need to know that Mars is not moving around the Earth. Both Mars and the Earth are moving around the sun. And without that knowledge, we would never be able to reach Mars. And so I think it's good for us to know the reality that we live. If there are neighbors, let's find about them, whatever we know. But hiding it makes no sense. So there are two options. either all of these stories are fabricated, or if they are real, they should be opened up for the public.
Well, lately, of course, there's a lot going on. The DoD released more footage now cleared for people to see. My question to you is: did you see the new footage? The DoD?
Yeah.
What
Oh,
did
no,
you
not the
think?
new photo. I didn't see the footage. No.
Okay.
Yeah.
Well, it's basically in line with whatever the military men noticed, like Fravor or Graves, the footage that's already going online. There's now like two more pieces of footage.
Oh,
Who's
okay.
to say?
I want to see that. Yeah, I will be glad to see that.
Well, it's FLIR camera footage, but there's a lot of things going on, like that the alien crash in LA, or maybe Mr. James Fox made a documentary about an encounter of the third kind in Brazil, like the Brazilian villagers seeing something that was not human. But let's take the LA case, which was very recent. This looks to me like a case that could be easily investigated by a scientist, right?
Yes.
So was that, for example, anything you guys were triggered by? Like, okay, let's look at this.
Well, that either the data is not available, or we didn't think that it's of good enough quality. I mean, I think the meat is really with data that is currently hidden from view, because we know that some officials, including Bill Nelson, said that the classified data convinced them. So we always see those marginal images that cannot really be convincing enough, because you don't know what the camera was doing at the time. So I would I would be very interested if there is high quality data to analyze it, but I haven't gotten access to such data as of yet. And obviously, I don't want to sign any NDA that limits my ability to function as a free, open scientist. So someone needs to decide to release that information.
I get it. Okay. I had a question in my head and now it's lost. You guys, damn it, I just lost it. I was trying to hold on to it so tight, but it just went. The thing I was wondering about was the Galileo project. There is a collab. Okay, so because there's so much attention going to these congressional hearings and these military men, telling their stories, and of course the Galileo project, collabing with Mr. Elizondo and stuff. Have you ever been approached by let's say, an agency to work with them on researching whatever, if there was something they encountered they couldn't place, or they want to know what it is?
No, I had visits to my home by people from AERO, the All Domain Anomaly Resolution Office, but never in the context of any data that they have that is not publicly available, nothing like that, no.
Okay. But let's talk about data. The Galileo project, so you said, you were all also using cameras, telescopes. Is there anything you got from that, looking into
Yeah, so we have a lot of data already, and I always ask my postdocs if they saw anything anomalous. And so, there were a few, but they ended up being a drone or something familiar, So we haven't seen yet an unidentified anomalous object that we cannot figure out, and it really looks strange. But we also, you have to understand, we are also using an observatory that is located on Harvard University property, not in the best site for seeing necessarily unidentified objects.
Ever went
So
to
we
Hesdalen?
Sorry?
Ever went to Hesdalen?
Say it again.
Hesdalen.
Oh, no. So we plan to have a copy of this actually to be assembled in Colorado. That's another place. And then after that, we have potential funders for about 4 other copies. That's a slow process because we're limited in funding at the moment, and very much hope that there will be more funding. And then, of course, we can entertain places outside of the US, as you just suggested. And but we need funding for that. We are basically operating already more than 2 years without additional funding relative to what we started from.
Avi, let me ask you this. I think it was the Webb telescope, or I'm not sure if it was the Webb, or a satellite or a Voyager that took an amazing picture. And basically was a game changer for whatever scientifically was perceived as. I think it was close to the birth of Earth. That picture they made, they've made. What do you think about that?
Yeah. So in terms of the Webb telescope, there are opportunities. I just wanted to add one sentence about what we said before, that if anyone is interested in funding the Galileo project, we just Google galileoproject.space. We have a website allowing people to support us. But with respect to the Webb telescope, what I wanted to mention is that if we find an object similar to Oumuamua, for example, that came from interstellar space, the Webb telescope allows us to get much more information than available before, because it's located 1.5 million kilometers away from Earth, the Webb telescope in the Lagrange point 2. And it therefore sees the object from a different direction than telescopes on Earth. So it's just like having 2 eyes looking at the object. You can pinpoint its distance very precisely and map its trajectory in 3 dimensions. And that would allow exquisite precision in telling whether the object has any propulsion, in addition to gravity acting on it. And moreover, the Webb telescope can detect the heat emitted by the object, so it can figure out its temperature and size. And altogether, much more information than was available for Oumuamua. So my hope is that indeed the Rubin Observatory in Chile, which will start operations next year and has a camera of 3.2 billion pixels, that's 1,000 times more pixels than you have in your cell phone camera. That telescope would survey the southern sky every 4 days. And it should find at least a few Oumuamua-like objects every year. And then we can potentially use the Webb telescope to look for them. And zoom on them and figure out their properties. But the Webb telescope also can check, distant planets. And that's what NASA talks about all the time, that it could be, for example, searching for molecules that are indicative of life, primitive life, microbial life, in the atmospheres of planets. It could also look for technological signatures. I wrote a paper about looking for industrial pollution in the atmosphere of a planet. And maybe the Webb telescope could do that.
So let me ask you this last question, because I know you're a very, very busy man. Let's talk about gravity a little bit more. So whatever you can photograph, or whatever you can put, in a picture with a Webb telescope or whatever, doesn't really matter if we do not understand gravity to its full extent, because it looks like whatever, let's say, the military men are encountering, or pilots or whatever, it's not behaving to the extent what we know of physics can do, right? So if what do we know about gravity? Like it seems to be something that can be manipulated. It can, if this is all theoretical, of course, I know, but it could potentially bend time. What role does gravity play in your research at this point?
Well, okay, so back 70 years ago, there was a physicist, astrophysicist named Hermann Bondi, who had an insight. He said, we all know about positive mass that attracts gravitationally other objects, right? That's why Newton saw the apple fall on his head in the orchard that his family owned, and he realized, oh, it's the force of gravity that is attractive. But just imagine that we could have a negative mass that would be repulsive gravitationally. Okay, you just reverse the sign of the mass. Just like in electricity, you can have a positive electric charge and a negative electric charge. And so if that's the case, and we can in principle, suppose we can engineer and create a negative mass, okay, and put it next to a positive mass of equal amount, what will happen? The negative mass will push the positive mass away from it. And the positive mass will attract the negative mass together with it. So they will move together, accelerating indefinitely to the speed of light without any fuel, no propulsion needed from conventional rockets or anything, just gravity. And that's what Bondi talked about in his paper from 73 years ago. And recently, I'm working on a paper that tries to ask the question, can we make a negative mass? Because if you imagine something like the Earth has the Earth mass, and you put another mass that is negative next to the Earth, it would basically accelerate the Earth at 1g, the same acceleration as we feel on the surface of Earth. And then these two objects will move together at 1g. If you continue at 1g for 1 year, you reach the speed of light, basically. And if you continue to accelerate at 1g beyond 1 year, let's say 20 years, then you reach the edge of the universe during your lifetime, during these 20 years. Because of time dilation, time is ticking much more slowly in your frame that is accelerating. So what I'm saying is, if we could engineer and create a negative mass, you could visit the edge of the universe in your lifetime, okay? Yeah. I'm now checking under which conditions you can potentially imagine creating a negative mass.
Well, this kind of brings me back to Oppenheimer, right? There's this chain reaction. they noticed while working on the H bomb, right? Like, is this something similar?
Right. Now, so what we are seeing, I mean, the only context where we see something like repulsive gravity is the accelerated expansion of the universe. The universe is not just expanding, but its expansion is accelerating over time, as if there was a repulsive force. And the explanation for that is called dark energy, or the cosmological constant. So we know that there is a constituent, the vacuum, that has a repulsive gravity. But the question is, can we engineer it to make an object, not uniform everywhere the way the vacuum is? Right. And that's the challenge, to make it, to make an object out of it, to engineer a repulsive gravity. It's something I'm thinking about. I wouldn't say that I'm optimistic that we can engineer it, but maybe someone else did.
Maybe someone else did.
Maybe.
Earthly.
So, if I ever encounter another scientist from a more advanced civilization, the first question I want to ask is, what was there before the Big Bang? Because I want to figure out how gravity and quantum mechanics are unified, and what were our cosmic roots? Was the universe created in a laboratory, for example? And the only way to figure it out is if you understand how to unify quantum mechanics and gravity, and perhaps at that point you can also make negative masses.
I get it. Well, some people say they're like there was matter retrieved on Earth, that's being back engineered, kind of like you are doing right now with the matter you're looking at. You're just like peeling it like an onion till its core, see what it's about, what it's composed of. So hypothetically, um, there the if there were someone or something that figured it out, and people are trying to reverse engineer it, that would give a huge boost to technology, right?
Yes, but I want to see that material before believing that they have it.
Of course. On that note, Mr. Avi Loeb, thank you so much for being on my podcast. I gotta tell you, you get me excited every time I talk to you. I just want to know everything about everything you are doing. Thank you so much, people. I will. Oh, by the way, we should talk about your book for a little bit.
All right.
Can you? Yeah.
It just came out last week, Interstellar, and it talks about many of the subjects we discussed. So I very much encourage anyone interested to look for it. And also my medium.com essays summarized. I just posted one before we spoke today, and I posted an essay, and you can follow up my research on medium.com. And it's for free. You can subscribe to it for free.
People, I really want to encourage you to support the Galileo project. Funding is needed. Avi is doing the divine work. As you've heard, some of his peers are being, critical or trying to sabotage whatever he's doing and the Galileo project. We need to support Avi and the Galileo project. He's doing amazing things. He's doing the pioneering. They're not. So please support him and the Galileo project. I will put everything in the feed. Also, Mr. Loeb and his team, they're being very transparent, so you can read all about the process of their research and just enjoy it. It's you're riding the wave of history in the making. All right, Mr. Loeb, thank you so much for being on my show. And
thanks for having me, man. It's always a pleasure.
My pleasure. And viewers, thank you for watching, and à la prochaine. Till the next time. All right. I'm going to end the broadcast now.